Hello dear student, this is your question. The question is I is equal to integration of 1 over x under root 1 plus log x dx. Here if we put log x is equal to t, then differentiation of t is 1 over x dx. So dx over x can be written as dt. So the integration can be written as integration of dt over under root 1 plus t, right? 1 plus t. Now again, if we put 1 plus t is equal to y, then dy is equal to dt. So this expression become dt. In place of dt we can write dy, and 1 plus t is y, so under root y. So integrating this one, I becomes y to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. This is equal to root y divided by 1 by 2, that is 2 root y. So returning to the value of y, I can be written as twice of y is nothing but 1 plus t, that is twice of 1 plus t, and this become 2 under root 1 plus, in place of t we can write log x. So with some integration constant c. So if we look at the option C is correct one. Hello dear student, this is your question. Here we have to find the integration of dx over under root 1 minus log x square, right? Now first of all, we here suppose that if we log x, if we differentiate the function log x, we get 1 over x dx. So suppose here t is equal to log x, so dt is equal to nothing but this is equal to 1 over x. Differentiation of log x is dx. So if we write this integration as I, this is equal to dx over x is dt over under root 1 minus log x is t square. Now as we know here, the integration of 1 over under root a square minus x square dx is equal to sine inverse x over a plus integration constant c. So this integration is one standard one in which value of a is equal to 1. So we find it after integration, I is equal to nothing but sine inverse t over a. The value of a is 1 plus integration constant c. So if we put the value of supposed t which is equal to log x, we get the required answer, and the final integration is sine inverse, the value of t is log x plus integration constant c. So this is our final answer. Hello dear student, this is your question. Here we have to find out the integration of e to the power x tan square e to the power x dx. So first of all, we write it as here I is equal to e to the power x tan square e to the power x dx. Now here if we substitute t is equal to e to the power x, right? So dt is equal to nothing but e to the power x dx. Now this part e to the power x dx become dt, and tan square e to the power x is equal to tan square t. So I can be written as integration of tan square t dt. Now as we know, tan square t can be written as integration of sec square t minus 1 dt, as sec square t minus tan square t is equal to 1. So tan square t is equal to sec square t minus 1 dt. Now integrating the same, we get integration of sec square t dt minus integration of dt. Now this I is equal to, as we know, integration of sec square t is nothing but tan t, and integration of dt is t plus integration constant c. So if we substitute the supposed value, I can be equal to, that is I is equal to tan into e to the power x minus e to the power x plus integration constant c. So if we look at the option here, we see that option D, which is equal to tan e to the power x minus e to the power x plus c, is correct one. So our option D is correct. Hello dear student, this is your question. This integration can be written as I is equal to integration of e to the power x e to the power log x to the power 3. Here the product of 3 is raised to the power x and the x4 plus 1 to the power minus 1 is getting in denominator, so this can be written as x to the power 4 plus 1. That is, here we simplify and rearrange the integration dx. Why we do so? Because if we put x to the power 4 plus 1 is equal to t, then dt is equal to 4x cube dx, right? So here this integration can be written as integration of x to the power 3 divided by x to the power 4 plus 1 dx. As we know, e to the power log e base e to the power x cube is x cube. Now we here multiply numerator by 4 and again divide it by 4 so that there is no change in integration. So I is equal to 1 over 4x cube dx is nothing but dt, integration of dt over x4 plus 1 is t. This become 1 over 4. After integrating, this is equal to log t plus integration constant c. So I is equal to half 1 by 4 log, returning to the value of t, which is equal to x4 plus 1, x4 plus 1 plus c. This is our answer. If we look at the option here this is 1 by 4. If we look at the option here, we get option B, that is 1 over 4 log x to the power 4 plus 1 plus c is correct one. Hello dear student, this is your question. So first of all, we assume that fx is equal to x minus 1 to the power 3 into x plus 2 to the power 5. Here we multiply numerator by x minus 1 and also divide it by x minus 1 to the power whole 4, right? So here we see that x minus 1 to the power 3 into x minus 1 is equal to x minus 1 to the power 4. So fourth root is taken outside, we get x minus 1. Similarly 4x plus 2, right? And the remaining portion is x minus 1 x plus 2 divided by x minus 1 to the power 1 by 4. Now here we assume that x plus 2 over x minus 1 is equal to t4. So after simplifying, we get here, if we simplify it, we get here x plus 2 is equal to t4 into x minus t4, and here we can write it as 2 plus t4 is equal to x into t4 plus 1. So x is equal to 2 plus t4 divided by t4 minus 1. t4 minus 1. Here if we take x right hand side, it is minus, so t4 minus 1. So here we have to find the value of x plus 1, x minus 1 and x plus 2. So see here, x minus 1 is equal to 2 plus t4 divided by t4 minus 1 minus 1, that is 2 plus t4 divided by t4 minus 1, and this is minus t4 minus plus 1, that is t4 cancel out. So x minus 1 is equal to 3 over t4 minus 1. So if we differentiate it, we get dx, and dx is equal to, see here, 3 into minus 1 into 4 t3 into t to the power 4 minus 1 to the power minus 2. So dx become minus 12 tq divided by t4 minus 1 to the power 4. Now we have to find the value of x plus 2. So x plus 2 is equal to we find that x is equal to t4 plus 2 divided by t4 minus 1 plus 2. So after simplification we get x plus 2 is equal to 3t4 divided by t4 minus 1. So now we integrate the given function. So integration can be written as I is equal to integration 1 over x minus 1 into x minus 2 into x plus 2 into x plus 2 divided by x minus 1 to the power 4 1 by 4 into dx, right? So here we have to put the value of the find one. So x minus 1 is equal to 3 into t to the power 4 minus 1 into x plus 2 is equal to 3t4 divided by t4 minus 1, right, into x plus 2 divided by x minus 3 to the power 1 by 4. This is equal to t, and dx is, as we find out, minus 12 tq divided by t4 minus 1 to the power 2 dt. Now we have to simplify this. So t4 minus t4, this one is cancelled out here, right? Now t3 is cancelled out with t4 and 3 minus 4. So overall integration can be written as I is equal to minus 4 over 3 integration of 1 over t square dt. So this can be find as 4 over 3 into t to the power minus 2 divided by minus 2 plus 1 divided by minus 2 plus 1. This is equal to 4 over 3, as minus 2 plus 1 is minus 1 and its multiplication with minus 4 by 3 4 over 3 multiply by 1 over t plus integration constant c. So if we put the value of t, we get the final answer is, final integration is 4 by 3 into 4th root of x minus 1 over x plus 2. Here we put t is equal to, t4 is equal to, see here, t4 is equal to x plus 2 divided by x minus 1. So if we find the value of 1 over t, this is equal to 4th root of x minus 1 divided by x plus 2. So hence I is equal to 4 over 3 into 4th root of x minus 1 divided by x plus 2 with integration constant c. So option A is correct one.